Welcome. So in the previous video, we have started a small signal analysis of FET and MOSFET, जिसमें हम लोगों ने देखा था transconductance, equation of transconductance, how we calculate the value of transconductance. So this is the transfer characteristics of the N-channel depletion type MOSFET. So the slope of this graph will be, what is the slope? Change in drain current upon change in gate to source voltage with respect to the VDS is called the slope of this graph, and slope of this graph is the transconductance, जिसमें GMO is the highest value of the transconductance. And another formula to calculate the GMO is 2IDSS upon Vp, where IDSS is the highest voltage or maximum voltage when maximum voltage of the drain current when VGS equal to 0. Now, if we know the GMO means highest value of the transconductance, then we calculate the GM at any value of VGS by putting the value of VGS and GMO in this equation. So this is the general equation of the transconductance, when GMO is the maximum value of the transconductance when VGS equal to 0, and Vp is the pinch off voltage and VGS is the applied voltage. Here we take the magnitude of the VGS and magnitude of the Vp. So this is the general equation of the transconductance. We have to remember this equation. If the numerical asks, then we have, by using this formula, we can calculate the transconductance. Gm equal to GMO bracket 1 minus mod of VGS upon mod of pinch off voltage means Vp. Now this is the transfer characteristics of N-channel enhancement type MOSFET. So from this graph, we can also calculate the transconductance, value of transconductance. The slope of this graph is called the transconductance, means Gm equal to change in drain current with respect to the change in gate to source voltage when VDS is constant. Now we have to calculate the output resistance of a small signal analysis. We have to calculate the output resistance. So we know the formula of the output. We know the formula of resistance. What is the formula of resistance? Change in output voltage upon change output voltage upon output current. This is the formula. Voltage equal to resistance equal to voltage upon current. So output resistance is equal to output voltage upon output current. Since output voltage is VDS and output current is IDS, so change in output voltage upon change in output current with respect to the VGS. When the input voltage is constant, then change in output voltage upon change in input voltage means if the VGS is constant, then change in output voltage upon change in input voltage. Change in output voltage upon change in output current is called RDS, means output resistance. So this is the drain characteristics of the MOSFET. So on x-axis VDS and upon y-axis ID. तो मैंने आपको बताया था कि due to the early effect, there is slightly drain current depends upon the VDS. So there is a small slope in the saturation region. This is the part of saturation region. So there is a small slope in the saturation region, and magnitude and formula of the slope we know. What is the formula of the slope? Change in change in y coordinate upon change in x coordinate. So upon the y coordinate it is drain current, and upon x coordinate it is the VDS. So the value of the slope will be change in output, change in drain current. Change in drain current means ID upon change in VDS. So this is the value of the slope. If we take the reciprocal of the slope, then this is the RDS. So RDS equal to 1 upon slope. So from the graph, we can observe that the slope of this graph is very, very small. So if the slope will be small, then the resistance will be high. Since resistance is reciprocal of the slope, so if the slope will be small, then resistance will be high. So this is the formula of the resistance, change in output voltage upon change in output current, and we can also calculate the output resistance by taking the reciprocal of the slope in the saturation region. So for the JFET, the value of the RDS is from 50 kilo ohm to several hundred ohm, and for the MOSFET it is up to 100 kilo ohm. So this is the approximate value of the output resistance for the JFET and the MOSFET. Now we have to draw the equivalent circuit diagram of the FET and MOSFET. So before हम लोगों ने BJT का इक्विवेलेंट सर्किट डायग्राम ड्रॉ किया था. हम लोग इक्विवेलेंट सर्किट डायग्राम क्यों ड्रॉ करते हैं? जब हम लोग AC एनालिसिस करते हैं आइदर BJT का और MOSFET का, तो हम लोग उसका इक्विवेलेंट सर्किट डायग्राम ड्रॉ करते हैं. इसीलिए हम AC एनालिसिस के लिए हम लोगों को इसका इक्विवेलेंट सर्किट डायग्राम ड्रॉ करना होता है. तो वी नो दैट MOSFET में अच्छा 4 टर्मिनल, इट इज द 4 टर्मिनल डिवाइस, लेकिन हम लोग क्या करते हैं बॉडी को और सोर्स को शॉर्ट सर्किट कर देते हैं. सो नाउ इट इज द 3 टर्मिनल डिवाइस. सो 1 टर्मिनल इज गेट, दिस इज द गेट, दिस इज द ड्रेन एंड लोअर पार्ट इज सोर्स. सो दिस इज द 3 टर्मिनल डिवाइस. That is gate, drain and source. So this is the gate, drain and source. To draw the equivalent resistance, we have to draw the equivalent capacitance between different junction, and we have to also draw the equivalent resistance between different junction. So C suffix GD is the capacitance between gate terminal and drain terminal. So this is the capacitance between gate terminal and the drain terminal. Similarly, CGS is the capacitance between gate terminal and source terminal, and RGS is the equivalent resistance between gate terminal and source terminal. Similarly, RDS is the output resistance between drain terminal and the source terminal, and this GM into VGS, since we know the formula of the transconductance is ID upon VGS, so ID equal to GM into VGS. So this is the value of the drain current. So in this equivalent circuit diagram, RDS is the output resistance and RDS is the output resistance, or RGS is the input resistance, and there are different capacitance between different junction. We know, हम लोग जानते हैं कि if there are two metallic plate parallel to each other, and if the charge is distributed upon the both plate, then the capacitance will be formed, and also we know the resistance. Now, so for simplicity purpose, we remove the capacitance between gate and drain, so it is the open circuit, and also we remove the capacitance between gate and source. Since the input resistance is very high, so we can replace this by the open circuit. So here we replace by the open circuit. So we are using, हम लोग यूज करेंगे this equivalent circuit for the AC analysis. So this is the gate terminal, this is the drain terminal, this is the source terminal. Since the output resistance between drain and source is RDS, this is the drain current, and since gate terminal is isolated from the source terminal, since the input resistance is very high for the MOSFET. So you have to remember this, you have to remember both equivalent circuit diagram, but for simplicity purpose we are using this equivalent circuit for the AC analysis. So for AC analysis there are 3 types of amplifier, same as a BJT में, since BJT is 3 terminal device, emitter, base and collector. तो 3 types के amplifier था, common emitter, common base and common collector. Similarly, MOSFET में भी 3 types of, there are 3 types of the amplifier. First is common source, then common drain and then the common gate. हम लोगों ने देखा था common emitter amplifier में emitter terminal is common between input and output. So similarly, in common source amplifier, source terminal is common between input and output. Similarly, common drain amplifier, drain terminal is common between input and output. And for common gate amplifier, the gate terminal is common between input and output. So first of all we will study the common source amplifier. सो हम लोगों ने जैसा बोला पहले कि इन कॉमन सोर्स एम्पलीफायर सोर्स टर्मिनल इज कॉमन बिटवीन बोथ इनपुट एंड आउटपुट. सो दिस इज द n channel junction field effect transistor. This is the n channel junction field effect. By observing the circuit diagram we can say that what is it is JFET, MOSFET or enhancement type MOSFET. So this is the n channel junction field effect transistor. So in the RD resistance, RD is connected to the VDD voltage, biasing voltage. Here we apply the load resistance, and since it is the common source amplifier, so source terminal, this is the source terminal, is common between both input, this is the input side and this is the output side. So it is common between both input and output, and here we connected to observe the output. To observe the output, here we connected the load resistance, means RL at the drain terminal. So load is connected. So C1 is the coupling capacitor. It couples the input to the JFET, and C2 is the bypass capacitor. हम लोगों ने coupling capacitor and bypass capacitor BJT amplifier में भी पढ़ा था. This is the RS source resistance, this is the RC means gate resistance, RD is the drain resistance. So this is the circuit diagram of the common source amplifier. Now we have to study the common source amplifier. What is the meaning of study? Means we first of all we will draw the equivalent circuit diagram of this circuit diagram. So for the AC analysis we replace the DC voltage by the short circuit, or we replace the capacitor by the also short circuit. So there are two capacitors C1 and C2. So we will replace C1 and C2 by the short circuit. If we replace C2 by the short circuit, then the R2 will, the equivalent resistance of RS and the short circuit will be 0, and C1 also replaced by the short circuit. VDD also replaced by the ground. So we will draw the equivalent circuit diagram, and then we calculate the voltage gain, input resistance and output resistance of the common source amplifier. So this is the equivalent circuit diagram of the common source amplifier. जैसा कि मैंने आपको बोला था कि C1 and C2 को replace by the short circuit. So यहाँ C1 था तो हमने क्या किया, C2 शॉर्ट सर्किट से रिप्लेस किया. अगेन C2 को क्या किया, शॉर्ट सर्किट से रिप्लेस किया. तो अगर C2 को शॉर्ट सर्किट से रिप्लेस करेंगे तो ये शॉर्ट सर्किट और ये RS दोनों का इक्विवेलेंट रेजिस्टेंस क्या हो जाएगा, 0. मींस इसको भी हम लोग RS को भी क्या किए, शॉर्ट सर्किट से रिप्लेस कर दिए. सिंस VD इज कनेक्टेड टू द ग्राउंड, सो हम लोगों ने VDD को ग्राउंड से कनेक्ट कर दिया. उसके बाद हम लोग क्या करेंगे, लोड रेजिस्टेंस यहाँ पे मिस कर गए हैं, तो यहाँ पे हम लोग क्या करेंगे, अगेन यहाँ पे लोड रेजिस्टेंस कनेक्ट कर देंगे. लोड रेजिस्टेंस मींस RL is also connected to ground. So this is the AC equivalent circuit. Now AC equivalent circuit के लिए क्या करेंगे, हम लोगों ने जो FET का जंक्शन फील्ड इफेक्टर का जो इक्विवेलेंट सर्किट डायग्राम है, तो जस्ट हम लोगों को क्या करना है, इसको जो ये सर्किट है आपका, इसको हम लोग किससे रिप्लेस कर देंगे, इस सर्किट से रिप्लेस कर देंगे. इस सर्किट से क्या कर देंगे, रिप्लेस कर देंगे. इसके लिए गेट टर्मिनल हो जाएगा, गेट टर्मिनल अगेन क्या हो जाएगा, RG एज इट इज रहेगा. ये देखिए एज इट इज रहेगा, सिर्फ क्या होगा, GM इंटू VGS, GM इंटू VGS, और क्या आ जाएगा, RDS आ जाएगा. उसके बाद RD और RL तो सेम रहेगा. तो सिर्फ हम लोगों ने ये एक्स्ट्रा सर्किट क्या किया, ऐड कर दिया. ये क्या किया, एक्स्ट्रा सर्किट ऐड कर दिया. इसको हम लोगों ने JFET को इससे रिप्लेस कर दिया. अभी हम लोग क्या करेंगे, देखेंगे. देखिए ये क्या है ना, RDS, RD एंड RL ऑल थ्री रेजिस्टेंस आर कनेक्टेड इन सीरीज और पैरेलल. ऑब्जर्व कीजिए, सिंपल है ऑब्जर्व करना, ऑल थ्री आर कनेक्टेड इन पैरेलल. सो इक्विवेलेंट रेजिस्टेंस को हम लोगों ने RD से डिनोट किया, स्मॉल r सफिक्स कैपिटल D. सो दिस इज द RD. सो दोनों का इक्विवेलेंट रेजिस्टेंस होगा RDS, RD एंड द RL. सिंस RDS क्या है, वेरी वेरी हाई, तो हम लोग क्या कर सकते हैं, इसको इक्विवेलेंट टू RD पैरेलल विद द RL लिख सकते हैं. सो दिस इज द इक्विवेलेंट रेजिस्टेंस ऑफ द ऑल थ्री रेजिस्टेंस. और GM, सिंस देखिए VGS, दिस इज द गेट टर्मिनल एंड दिस इज द सोर्स टर्मिनल. सो VGS इक्वल टू इनपुट वोल्टेज, इक्वल टू इनपुट वोल्टेज. इसीलिए हम लोगों ने यहाँ क्या, VGS को किससे रिप्लेस कर दिया, सिंस VGS इज इक्वल टू इनपुट वोल्टेज. तो हम लोगों ने VGS को क्या रिप्लेस कर दिया, VGS को इनपुट वोल्टेज से रिप्लेस कर दिया. नाउ दिस इज द सिंप्लीफाइड ऑफ द AC इक्विवेलेंट सर्किट ऑफ द कॉमन सोर्स एम्पलीफायर. So we can calculate the output voltage. What is the output voltage? Means रेजिस्टेंस, आउटपुट रेजिस्टेंस इनटू आउटपुट करंट। सो आउटपुट रेजिस्टेंस क्या होगा अगर हम लोग ऐसे मूव करेंगे, आउटपुट रेजिस्टेंस क्या होगा अगर करंट का डायरेक्शन ये है तो करंट का डायरेक्शन ऐसे भी मूव करेगा, करंट का डायरेक्शन तो हम लोग इस डायरेक्शन में लेंगे तो ये क्या हो जाएगा माइनस,